All right, let's talk about a technology that's quietly working all around you right now, making everything from your phone to your car way faster and a whole lot smarter. It's called edge computing, and honestly, it might just be the next massive revolution for the internet as we know it. So, to really get why we even need this revolution, we have to start with a number. And I mean a really, really big number 175 zettabytes. That is the insane amount of data the world is expected to be creating every single year by 2025. Just so you know, 1 zettabyte is a trillion gigabytes. We are literally creating a tidal wave of data. And our current systems, well, they're starting to buckle under the pressure. So, what are we going to do with all that data? Where does it get processed? Well, right now, about 90% of it travels all the way to these huge centralized cloud data centers. But, according to the research firm Gartner, that's about to completely flip. By 2025, they're predicting that a staggering 75% of data will be processed locally, at the edge. That's not just a small change. That's a massive shift away from the cloud-first world we've all gotten so used to. And that leads us to a pretty critical question, doesn't it? When you think about a future filled with self-driving cars, instant AI, and smart cities that run themselves, is the cloud, as we know it today, really enough? You see, that long journey from your device to a data center maybe thousands of miles away and all the way back again, that's starting to become a real bottleneck. Okay, so how do we solve this? Let's use a simple analogy. Think of the traditional cloud like a giant central warehouse. It's huge, it's powerful, it can store absolutely everything you need. But it's far away. Every single time you need something, you have to send a truck on this long journey just to go get it. Now, edge computing, that's more like a whole network of local pop-up shops. They're smaller for sure, but they are right there in your neighborhood, giving you what you need almost instantly. So that's the analogy. Officially, here's what edge computing is. It's a distributed model, which just means it pushes the actual computing and the data storage closer to where the data is being created in the first place. The goal here is simple, but it is profound. Cut down on that travel time, that's what we call latency, and save the incredible amount of bandwidth it takes to send everything back and forth to that faraway cloud warehouse. You know, this idea isn't totally new. It actually has roots back in the 90s with something called content delivery networks, or CDNs. Those were just servers that stored copies of websites and videos closer to you to make them load faster. But the real game changer, the thing that made this explode, has been the rise of the Internet of Things. We're talking billions of smart devices, sensors, cameras, all creating these constant streams of data that need to be dealt with right away. To really get why right away is so important, let's set a little benchmark. You. When you see a face, your brain takes somewhere between 370 and 620 milliseconds to recognize it. That's our biological standard for what feels like a real-time interaction. For technology to feel seamless, to feel natural, it's got to get pretty close to that speed. And here's the difference in the real world. A round trip to a traditional cloud server, that can take about 600 milliseconds, which is right on the edge of what our brains perceive as a delay. You know that tiny, annoying lag on a video call? That's what we're talking about. By processing data locally, edge computing can slash that time to under 50 milliseconds. We're talking about the difference between a noticeable lag and a truly instantaneous reaction. So here's the bottom line. For any application where every single millisecond counts, and think about things like augmented reality headsets or self-driving cars, edge computing isn't just a nice to have, it's an absolute necessity. It's the technology that makes all those futuristic ideas actually work. But you know what? It's about way more than just speed. Edge computing has other huge advantages. It's way more efficient. For instance, your voice assistant can figure out what you said on the device itself and just send the tiny text command to the cloud instead of the whole giant audio file. That saves a ton of bandwidth. It's also more reliable. Your smart home can keep working even if your internet goes out. And this is a big one. It can be way more private because you can keep sensitive data, like a security camera feed, on your local network instead of constantly sending it to some corporate server. Of course, it's not a perfect, magical solution. Spreading all this computing power out everywhere creates new kinds of challenges. Instead of securing one giant data center, companies now have to figure out how to secure thousands, maybe millions of these smaller edge devices. And managing software updates across so many different pieces of hardware is incredibly complex. Plus, you have to ensure things stay reliable when any one of those local devices could fail. It's a whole new set of engineering puzzles to solve. But even with those challenges, the potential is being unlocked as we speak. This isn't science fiction.
Self-driving cars rely on edge computing to make those life or death decisions in a split second, without ever waiting for a signal from the cloud. Smart cities use it to manage traffic lights based on the actual flow of cars, right now. That powerful AI on your phone that does facial recognition, that's Edge AI. And modern factories are using it to analyze data from machinery instantly to stop failures before they even happen. All of this brings us to a final, really thought-provoking question. We are moving away from a world with a few giant centralized brains in the cloud to a world with billions of smaller, distributed brains all around us. So, what happens when everything from your car to your home to maybe even the glasses on your face becomes its own tiny intelligent data center? That's the future edge computing is building, 1 millisecond at a time.